I thought I would do a bonus video. We're going to look at some stuff that I have. Most of this I've used in other videos. I have not used this inverter at all, or the connectors that come with it. So if you want to power the inverter from a cigarette lighter of a vehicle, and it's got a warning here, make sure load under 300 watts. You don't want to it's 12 volts. You don't want to put too much current through it. You could damage something, maybe a vehicle, or maybe this. So I don't know the details of that warning. That'd be something you'd want to look into. But we got the two plugs there. Again, we're not going to look at these connectors too much. I'm going to use my power supply here as shown. But we also got these connectors, and you can see we got those there. These you can attach directly to a battery or any other power source. This is only rated for 12 volts. We'll come back to that. We're going to just use the USB ports of this for this video. We're going to stay very low power, just the USB port. So we got the USB to alligator clips, which I'm actually going to plug into my USB meter right here. And for our load, we're going to be dealing with 5 volts. This is a 5 ohm resistor rated for 10 watts. So you can see how large it is. This is 10 watts. These are quarter watt resistors right there. You can see the size difference. High wattage generally means that depending on the material, if it's the same material, it has to be a lot larger to dissipate more heat. And so there you can see that's why this is 10 watts. Those are quarter watts. This can dissipate 40 times as much heat right there. And it's probably more than 40 times larger. So now here is the inverter. I bought it maybe 3 years ago and have never used it at all until today. So we're going to take a closer look, and this is where you connect the 12 volts. Let's see if we can see the label. Please tighten them. That's all it's really saying. And you want to make as much metal to metal contact as possible. So we have a cooling fan here, and we can replace the fuses. So it has AC outputs. That's what this switch is for, as we'll look at. Once we apply power, so looks like this is really only intended for about 12 volts. So we're going to look at that a little bit later. We're going to keep an eye on the power fault here. But we're not going to do a ton of testing. I don't know the specifics of the voltage range this can handle. But in any case, it only says 12 volts. So I've been looking at some other DC power that outputs 4 of the USB, the one in particular I was looking at, and it has a range of I think 9 volts to 36 volts. So within that range, it'll convert it to the USB 5 volts according to the ad. And I was thinking about buying that, but I figured instead I'll look at what I already got. So we got some USB there and the output. So for the this is rated for 400 watts, as we saw. The cigarette lighter one said only use 300 watts, and maybe even that's too much, I don't know, but seems kind of high to expect from a vehicle. But in any case, output 110 volts alternating current. So that's not going to be smooth. It's going to kind of jump up and down. Alternating current means it goes one way then the other, and so it doesn't have, there's called a sine wave, kind of goes up and then down. Actually, when it goes down about halfway, it starts going the other direction, the other way. This probably steps up a bit, steps up a bit, steps down a bit, comes back to 0, and then goes to the negative voltage, down a little bit more, and then back up. So it probably steps. But in any case, we have 110 volts right there to 400 watts. So that's 3.6 amps, but that's out. To step up the voltage, you need more current coming in than is going out. So I'm guessing that's 12 volts there, and with conversion, if you have 12 volts, 39.2 amps coming in, you can probably expect 110 volts out at up to about 3.6 amps right there. So I'm assuming that's a proper conversion right there. But in case, looks like with the USB, you can probably use all 4 of them or less than 4. But altogether, it looks like you only want to use 4.2 amps max, even though the numbers on them could probably output higher than that. So now we come to the power supply. The output's on. We got the banana plugs right there, plugged into the board. I think that's what you called. And the other end of them are these alligator clips here. So the output's on right now. If we short circuit them, it will turn off. We're not going to worry about that too much. This video, we're just going to look at the settings. So I can get the voltage down to 0.3 volts, be an output, up to 3.75 amps right there. And we don't have any current going out right now. We're not powering anything. So we can press that to either look at the voltage it's outputting or the current that it is outputting. But we're going to hit set there. So now it went to voltage, and this is VA for voltage, amps, and we can make adjustments that way. So I set that up as high as it will go right now. We can look at that. I can try to set it higher. It's not going to go any higher. We're going to go to voltage though. We can definitely get the voltage higher, and watch this current. So we're going to go up to, let's see, 10, 11, 12, 13, 14. There we go, at 14.3 volts. Now you see it's outputting less current. That's because it also has a wattage that it can output. So as voltage goes up, the amount of current it can provide goes down. So that's an important thing to remember about this power supply. So one reason why I was thinking about buying that USB adapter that takes DC in higher voltage and then outputs 5 volt USB is because I could put a higher voltage for this power supply and test it out, see if it goes up to that voltage. But we are limited to the current there, so that's why I was interested in getting it. Now of course we don't have to leave the current this high. We got the right, left there, down, and so that put the voltage down. Pressing down, pressing up brings the voltage up. That's how you make the changes. But in any case, this is kind of versatile. What we're going to do is set this at about 12, or we're going to set it at 12, and just for no reason, I'm going to limit current to about 1 amp right there. Close enough. So that's all we're going to look at for the power supply right there. For the inverter, we have the DC input right here, and it's pretty straightforward. You can see that the connectors we had before were round. You would screw this all the way off, slide that over the screw there, and then screw it back down and tighten it. But we're going to use alligator clips from this power supply right there. And so I'm just going to clip it right to the post there, the screw, whatever you call it. And one thing you're going to notice, once I connected them, we got a little bit of current right there. So the USB starts right away, even with this off, which is nice. That's what I was hoping for. And so I'm going to screw it down a little bit, and not too tight though. Those are alligator clips. So we got the power button. If I hit the power button, hopefully this isn't too annoying, you can hear a fan kick in, and so that's the current that the fan needs. So that must mean the AC outputs are on. You can also see power fault right here. So let's actually look at that really quick. So power fault with 12 volts. Let's raise the voltage. 13, 14. So fan is going harder. 15, it's still green. I like that. 16, it goes red. Now we get back down to, I think it went to 15, it turned green again. Nope, had to go down to 14 to turn green again. So if we go too low, so I think that turns AC off. If we go too low, then it goes red, and I believe it, there we go, we gotta go up to 13 to get it back. So that's kind of interesting. So I think the output's going off, but I don't know for sure. That would be more testing. Maybe a different video right there. This video, we're not going to worry about AC at all. Here is my DROC USB multimeter, basically, USB tester. And what's really nice about it is all you have to do is plug it into a USB power source right there. And yeah, I think that's the right way. I'm just going to use this one. And you can see that voltage that it's outputting right there. Really, really nice. Now, so we got 5 volts coming out. Let's make sure it stays 5 volts as we increase the supply voltage. So that looks good. I don't know if it would change under load. And we got 16, 17, still shows 5 volts. So looks like USB might be able to have a higher voltage and still output. Let's go down and see if it cuts off really quick. So it just went down a little, but there was no load. I bet it would have gone down. And there we got 4 volts, and that's what it was outputting. So I don't know if that's bad for things. But in any case, I do like at least 6 volts. Looks like you'll have the 5 volts there. So that brings us to some more testing we're going to do really quick. We got our resistor again, and we have this USB to alligator clip right there. I think it'd be better to power stuff with this connector down here. That's got the USB, I don't know why, logo on there. And maybe it's safer. Maybe phones will prefer this one better. I think that might be what it is. A lot of phones, they don't trust a power source that's powering them with USB, and so they greatly limit how much current they'll allow to flow in there. They self-protect or something, and so maybe that's what it is. So this resistor gets really, really hot, so I don't want to accidentally touch it. And let's try to I was doing a better job holding this before, but there we go. Now I'm going to connect this, and you're going to see the current on the display. So this is a 5 ohm resistor, and we got 5 volts across it. That's 1 amp of current. And there you can see we got less than 1 amp of current, but we got that conversion. So there you can see, according to this, it's actually 0.93 amps. This current, though, is also powering the DC to USB conversion. So some of that current may be lost, and the unit here is going to use a little bit of current. So that's actually going to be a little bit lower. That's being converted, but that's the total current being used right there. But there you can see, since we have about twice the voltage, let's keep the math easy, being converted to about half the voltage, that means we have to have about half the current being provided to output. Twice as much current right there. It's half the voltage, twice the current, and then twice the voltage, half the current. That's how voltage conversion goes if it's completely perfect. So in case we have that, let's test the I don't want to melt that plastic. Let's test the voltage again. So 14, 15, 16. So as voltage goes up, it needs to output less current to be converted, as I said before. And 18, 19, 20. So I'm going to go all the way up to 30. Hopefully I don't damage the unit, but if I do, oh well. And there we go, 30 volts. Looks like it's doing pretty good right there, USB wise. And then let's see how low we can go. So this unit is made to work on batteries. I'm assuming lead acid battery, but hopefully also lithium ion. I want to make a lithium ion battery pack. So there you can see we only got about a volt higher coming in than is going out, and so we got almost as much current coming in as is coming out of the unit right there, as we discussed before. And then if we go lower, looks like it's pretty safe to go lower. Alright, to cut off the output, and I don't know what it was doing there. So looks like maybe 6 volts at 1 amp is okay. But in any case, we're going to go back to 12. So this whole video, basically, I'm simulating a 12 volt battery source or other. This is going to be very hot. Even the wires might get a bit hot. Might want to wait a little while. Unplug one and wait a little bit. But there we go. Luckily I didn't burn myself. And that's it. It was just a bonus video. I didn't plan it out. So hopefully you still enjoyed. And I'm going to put this back to 5 volts actually, because let's not worry about the USB. We already exceeded this. Because when I power circuits, usually I power them at 5 volts. And so I don't want to accidentally try to power a circuit made for 5 volts at 12 volts. So I'm going to put it back to 5, since that's generally what I assume it's at. And we can look at how much current that needs. So looks like about 15 milliamps of current. Once I unplugged it, it went down about 15 milliamps, which makes sense. That was LEDs. And I'll unconnect the power supply here, and we'll drop that other voltage. So if you're connected battery to this, only about 5 milliamps of current is used if you have the USB setting. As you saw before, the fan goes way up. So you don't have to worry really about leaving this plugged into a large battery bank. It's hardly using any current if it's not powering anything with USB and the AC is off. So in any case, again, hope you enjoyed. Check out one of the other videos I'm posting on the screen, and check out the links down below. They all help a lot. I'll see you in the next video.